Hi, in this lesson, we are looking at the particulate nature of matter. In our previous lesson, we saw that matter is anything which has mass and occupies space, where we saw that the space occupied by anything is volume. And so we can also define matter as anything which has mass and volume. And we gave some examples of matter to be stone, an exercise book, bottle, the mirror, and so on. And we also saw that we are surrounded by items that are made up of matter. But in this lesson, we want to look at what actually makes up matter. All the examples of matter, or anything which is considered as matter, is made up of tiny substances that the eyes can't see. And these tiny substances are called particles. They are called particles. So a particle is simply anything which is so tiny that the human eye cannot see. So, in this lesson, like I said, we are just looking at matter being composed of tiny substances that we can't see. And these tiny substances are what you call particle. So, for example, if we take a look at a solid, so it can be any solid, stone, exercise book. This solid was actually formed by tiny particles, or let's say very tiny substances coming together to form the solid. So it could be a stone, it could be an exercise book, it could be anything. So these tiny substances, which is called particles, actually came together to form the solid. You can also take a look at a liquid like water. Liquid like water also came about as a result of tiny substances, which is called particles, coming together to form the liquid. And they mostly come about to form the solid or liquid by arrangement. All right. And so the idea that matter is composed or made up of very tiny particles is what you call the particulate nature of matter. So the particulate nature of matter is defined as the idea that matter is made up of very tiny particles. Now, what are these tiny particles? What are they? In the early 500 BC, there was a man by name Democritus. He did a study into what matter is composed of. And per his study, realized that these tiny particles which matter is composed of is actually atom. From the Greek word atomos, which means indivisible. So Democritus in the early 500 BC was able to come up with the fact that the tiny particles which matter contain are actually atoms. Other early scientists also came to embrace the fact that matter indeed contains tiny particles, very tiny particles, which we can't see. But they went a bit further, and they also realized from their experiments that these very tiny particles are not only atoms, but they could also be what we call molecules or what we call ions. So their experiment embraced the fact that indeed matter contains very tiny particles. But these tiny particles are not only atoms, but they are also molecules and ions. And so in the 21st century, the very tiny particles that make up matter are atoms, molecules, and ions. All right. And atoms, molecules, and ions are what we refer to as the building blocks of matter. The building blocks of matter. Building blocks of matter. So the building blocks of matter are atoms, molecules, and ions. So what it means is that every matter that you pick, for example, a solid, it could either contain very tiny particles which will be in the form of either atom, molecules, or ions. If you pick liquid like water, which is matter, it could also contain either atoms, molecules, or ions. So the very tiny particles we are talking about, which matter is made up of, can either be atoms, molecules, and ions. Therefore, these are the building blocks of matter. Now, how do we know that indeed matter is made up of very tiny particles, which are atoms, molecules, or ions? So, briefly, let's look at evidence to show that matter indeed contains tiny particles. So we are looking at evidence of particulate nature of matter. Evidence of particulate nature of matter. So the first evidence we are going to talk about is the spread of dye in water. Let's consider this container containing water, and we drop, let's say, 2 specks of a dye in it. Now remember that the dye we are dropping in the water is matter. All right, so we want to prove whether this dye actually contains very tiny particles. Okay, now let me also add that these very tiny particles we are talking about, they can actually move. They have the tendency to move. Okay, so we just drop 2 specks of dye or 2 particles of dye in water. After some time, we'll realize that this dye begins to spread throughout the entire water. And therefore, the water begins to assume the color of the dye. The fact that the dye was able to spread through water proves that the dye, which is actually matter, contains tiny particles which are in motion. Remember, I've said that these tiny particles have the tendency to move. All right. So the fact that the dye, which is matter, was able to spread through water shows that they contain tiny particles which were able to move and cover the entire water. Now, the property of any substance to spread through an available space uniformly. We call it diffusion. We call it diffusion. So over here we can see that the dye diffused through the water. All right. That is, was able to spread through evenly throughout the water. So that's the first evidence of the particulate nature of matter. The second evidence of particulate nature of matter is the spread of perfume. The spread of perfume. I believe one way or the other we've come across a perfume. Now let's just say that this is one corner of a room. This is one corner of a room. And then you spray a perfume at this corner. You agree with me that after some time, the scent of the perfume can be smelled all over the room. All over the room. Now, the very fact that the perfume was able to spread all over the room shows that the perfume, which is matter, contains tiny particles. Remember, once again, tiny particles have the tendency to move. So we were able to smell, or we will be able to smell the scent of the perfume because the perfume, which is actually matter, contains tiny particles which are in movement or in motion. So that is the second evidence of particulate nature of matter. Remember that this concept also falls under diffusion, because diffusion is the spread of a substance uniformly through an available space. So actually, diffusion is one of the evidences of particulate nature of matter. All right. Now let's look at the third evidence of particulate nature of matter: crystallization. Now, when we talk of crystallization, we are just talking about the process by which crystals are formed. And this method is mostly applied in the production of salt. Right? Now, to produce salt from seawater, if you fetch a seawater, you can't see the salt in it because the salts are dissolved in the water. Now, if we are able to add a substance to this seawater, which causes the salt in the water to be seen as solids on the surface of the water, we call it crystallization. Now, the salts were able to come to the surface of the water upon addition of the chemical substance because the individual salt particles which were dissolved came together, all right, to form a big substance, which we call the crystal. All right, which we call the crystal. So the very fact that the tiny particles of salt which we couldn't see in the seawater were able to come together to form the big solid here, which is called crystal, shows that matter indeed contains very tiny particles which we can't see. All right. So I'll end it here. In our next video, we are going to look at the tiny particles in details. In our next video, we'll be looking at atoms, molecules, and ions. atoms, molecules, and ions. So I want you to kindly subscribe to this channel, and I want you to look forward to the next lesson. Thank you for watching this video.